Imagine, you toss a plastic bottle into the trash. In 450 years, it's still there, in the ocean, a landfill, or inside a turtle. Now, another scenario. That same bottle vanishes in 48 hours. It doesn't burn, it isn't buried, it literally dissolves. It's eaten by microscopic organisms that turn it back into raw material for brand new bottles. Sound like sci-fi? In 2016, Japanese scientists found a bacterium in a landfill that does exactly that. In 2022, I made it 10 times better. Today, I'll show you how biology and artificial intelligence are creating a technology to close the loop on plastic pollution and why it's not happening everywhere yet. For a long time, plastic was considered eternal. Its polymer chains are so strong that nature hadn't evolved a way to break them. But evolution is catching up. Recycling used to mean melting plastic with a loss in quality. Now it's enzymatic breakdown into monomers, creating plastic identical to new. Decomposition time has dropped from 4 centuries to just 24 to 48 hours in the lab. While global recycling is only at 9%, pilot plants are reaching a 90% recovery rate. In 2016, there was 1 bacterium. In 2024, we have 12 strains, from Pakistani landfills to the Arctic. We have fungi eating polyurethane, and modified E. coli turning PET into vanillin. But the real revolution started when AI entered the game. Case 1. Ideonella sakaiensis. In 2016, Japan, researchers found a microbe that survived where everything else died from plastic toxicity. It uses FAST-PETase and MHETase to break plastic down into fuel. In the lab, it finished a bottle in 6 weeks, the first full natural cycle. Case 2. FAST-PETase. In 2022, AI analyzed enzyme structures and suggested mutations. FAST-PETase works at 50 degrees Celsius and degrades 90% of plastic in 24 hours. This isn't downcycling, it's an infinite loop of high-quality material. Case 3. Carbiose. A French plant in Lyon now processes 250 kilograms of plastic a day. In 16 hours, they get pure monomers with a 60% lower carbon footprint than oil-based plastic. They've signed L'Oreal, Nestlé, and PepsiCo. Case 4. Unexpected players. Pseudomonas putida turns 3 kilograms of bags into a liter of jet fuel. Aspergillus tuberculosis fungi break unbreakable urethane bonds in 2 months. Why not release them into the ocean? It's ecological Russian roulette. They could mutate to attack natural cellulose in algae or chitin in crab shells. The paths forward: controlled zones, smart microbes with genetic kill switches, or closed-loop factories. We're taking the third path. What about the rest? PET is only 12% of waste. Bags and pipes have bonds stronger than diamonds. Nov 2023, a Chinese lab created an enzyme for polyethylene. It's slow, 5% a month, but by 2030, we expect AI-designed synthetic proteins for all plastics. Is this a solution or a crutch? I believe it's a tool to clean 6 billion tons of existing waste, but it doesn't replace systemic change. Biology plus AI equals turning waste into resource. By 2030, landfills will be biomines. Your roadmap. Consumer. Watch for enzymatic recycling labels in 2025. Investor. The sector is growing 40% annually. Entrepreneur. Look into waste collection logistics. Everyone. Keep reducing plastic use. Microbes are a system fix, not an excuse. Check the calculator in the description to see how long microbes need for your weekly trash. Question: a total plastic ban in 5 years or perfect 90% recycling with no limits? Tell me in the comments.